Hello everybody and welcome to yet another summary video. We had a live coding session number 5, so this is summary number 5 for our project Trivia, where we build a trivia game in Clojure and ClojureScript. And let's take a look at what we did during the last live session. The goal was to add support for database interactions. So at the end of number 4 we had a application, a game that was fully running from an in-memory database. And the good thing would be to have a database that we can actually talk to. Also with number 4, we were able afterwards to run it on Heroku. So what is available on Heroku, you can add PostgreSQL databases to your instance. And for the development, you can actually have a free instance that goes up to 10,000 rows. So I figured that would be a good thing to do. So I added a PostgreSQL database to my Heroku instance. And you can see it right here. It's loading. There we go. And it's as you can see, it is running. It is being used by 3 connections. It has 4 tables, and this was the end result of our live coding session. So how did we get there? Well, we had to first have a development environment, and that is something we did by using a Docker. We created a Postgres instance, a container, which is just done through clicking the new button and typing Postgres. You just take the top one. One thing that we did in the settings is to add a Postgres password so that we have a full a JDBC URL that we can utilize. And in that database, we normally would just create some tables and add some data, but then when you deploy it, how do you get it there, right? So what we want to end up with was a set of tables that have questions, that have answers, and that link the questions with the answers. So for instance, you can have the answer Amsterdam being the answer for multiple questions. For instance, what city is in the Netherlands? Amsterdam. And what is the capital of North Holland within the Netherlands? That's also Amsterdam. So linking the question to the answer would just involve having a question ID, an answer ID, and an indicator to see if it's correct or not. So we created those, and but one thing that we want to do is that when we deploy an application, it would actually build up this database when the tables are not there yet. So for that, we added the JDBC interaction to our project. So let's take a look at the project itself. Of course, we needed to add some more libraries. First one being Migradis, which is the package that we use for schema migration, so going from nothing to having those tables that we require. Of course, we need some form of JDBC driver within the Java framework. Virtual machine JDBC is the protocol that you use to actually talk to databases. On Heroku, we used the Heroku description of setting up the C3P0 connection pooling, which is very important on Heroku because you're limited to the number of connections. We just used the provided instructions. As it turns out, at the end of the session, it failed to start on Heroku. After debugging it some bit later, I found out that the instructions on Heroku actually tell you to use a earlier JDBC version, which caused the error. So upgrading it to the most recent version fixed it. So everybody's happy. Then we also added 2 libraries for logging, Timber and SLF4j Timber. They provide normal logging. It tells you a timestamp, a level, and a message, which is exactly what you want. When running on Heroku, we can see the logs, and so it's nice to have a concise image of what is going on. And the last one that we added was the actual PostgreSQL driver. We actually first took the wrong driver, which made it fail quite miserably. Luckily, the internet was very kind and gave us the right answer, because they recently switched from the namespacing. So adding those libraries will cause our project to be useful for database interactions. And so we start to think about migrations. How do you want to handle those? And we figured out that it would be a good idea to have them run every time our application starts. When you have a large application, you would want to have this as a separate entity. But for us, we have a small application. We want to be sure that the database is updated every time we start our application, so that we can have the most recent or most up-to-date version of the database. So we decide to add a component for it. So where's the system? Here's the system. So we changed our system a little bit. We added a new component for the connection pool, and we did this so that not only our migration can use this connection pool, this connection to the database, but also our actual database, which currently is an in-memory database, so it doesn't need it. But in our next session, we will change it to an actual instance that will use the data in the Heroku database. So with this, we were able to say, let's create a component that deals with only the database connection and the connection pooling, because we found out already that the C3P0 is quite verbose in its logging. So I'm not sure if we like it, but this setup means that when we want to change out the JDBC connection pooling, we can just change this component and the rest of the project will not be troubled with it. We added some dependencies on the connection URL. There's actually an environment usage from the database URL that is given in the environment. So if you go to the profiles, we see that we actually have this database URL property available in our environment, which also means that on Heroku we need to set it in our environment variables. Very important, you should not forget that. So given that, all we do is basically say create this connection pool and add it to the component as the key spec. And then from our other component, which is actually the migration part, we get this connection pool passed along through the component architecture. So when our application starts, it will feed the pool to this component, and then when we start our migrations, we can tell it to have a certain configuration and then use the specification that we actually added to the connection pool and use that to run the migrations. And in this case, we tell the migration to have run a migration for a database. You can use migrators to migrate several other things as well. And then read the migrations from the directory migrations, which is actually under resources. So, because resources is added to the class path, then migrations become available. And we have many tables, one for question, or we have three tables really, one for answer and one for question answer, which is the linkage between the question and the answer. And then we added some data by just saying, is this working? Yes, no, maybe, definitely. And then connecting those two to make sure that our actual data is getting into the database. And so what happens when you actually start the application, it will migrate your database from an empty state to one that has data in these tables. And so when you look up the question answer table, it will actually have the data that we provided here, which is awesome, really, because when you have changes to your system, you just add a new migration, which is actually, well, let's close these, which can actually be done by just calling a migrators create, and it will actually create this file question in the migrations directory with the timestamp of now, and then you just add your statements to it, and they will be run whenever we do a fresh reload of our application. And if you remember from the previous session, or actually the video about Heroku afterwards, is that when we commit our application to the GitLab repository, it will actually go and push itself to Heroku, which is done in the pipeline, the build pipeline. Let's wait for it to load. There we go. So after running the tests, for which we don't have a lot, it will go into deploy. It will go deploy to staging. And here you see that after a lot of steps, it will actually deploy the application to Heroku. So it says for it's authenticated as myself, it's building the build fun things, and then it will actually deploy the application. It takes a little bit, and then it starts to compile it and do all the things that it needs to be done. And if we then take a look at the output for Heroku, somewhere along these lines, the C3P0 is quite noisy, which is quite annoying. You will see that here it says ending migration, and on the top here it should say somewhere starting migrations, and all the other noise, the stack traces, because it cannot find certain files on the class path, which is actually debug information, and it should not be here. It's a little bit verbose for my taste. But so when it starts up the application, it will actually perform the migration, and that will bring our application to the level that it has a database in which there will be data, currently one question, and then we can start reading from it. And that's where we actually left off. After about an hour and a half, hour 3/4, we had this working system of having a database connection, having migrations being run successfully. We spent a lot of time talking about why and how the migrations work, and what we should do with the connection pooling and why it is useful. So it was a very good session. I think we did accomplished a lot. And so for next week, we will actually start and use this data from the database. So our application will transform from something that uses an in-memory database to a PostgreSQL using application. And remember, it's all for free still. It's in a free tier of Heroku. So you can do this yourself without having any cost. So you can play with it. Adding the Heroku hobby dev PostgreSQL was quite easy. Just click add and you select it. So next week we will actually use this. For now, take a look at the source code, take a look at all the steps that were needed. And then I will see you next Friday to actually use this data. And our application will become much more rounded. See you next week, Friday. Be sure to click subscribe if you have not already. It's down here somewhere, I believe here. If you like this video, give it a thumbs up. and see you on Friday.